Before explaining the general method, let me solve this particular ODE step by step. It's actually pretty funny. So in order to solve a separable differential equation, what we need to do, the idea is to separate the variables. So we move dt as if it were just a variable to the right hand side. So we sort of, in a way, we multiply both left and right of the equation by dt, and y to the left hand side, right? So in other words, we move everything with one variable to on one side and everything with the other variable on the other side, so thus separating the variables, right? So then we get dy over y squared equals cosine t dt. So the first step is done. We have separated the variables. So then we introduce the integration. Then we do integration. So the antiderivative of 1 over y squared is minus 1 over y. The antiderivative of cosine is sine. And please let's not forget about the plus constant. That's basically it. So the rest is just to solve for y. Y equals minus 1 over sine t plus constant. Well, if you are a very thorough person, then you would probably notice that I kind of make a little mistake. Well, it's not a mistake, it is, the solution is incomplete. So because when we divide by y, we are assuming that y cannot be equal to 0, right? But in the original equation there is nothing that tells us that y is not allowed to be equal to 0. Right? So in other words, we need to verify, to check the case y equals 0 separately. So how do we do this? Actually, if y is 0, then the question is whether or not 0 is a solution of the differential equation, of the original differential equation. Right? So in other words, when we assume that y is 0, we should try it as a solution of the original differential equation. So we should substitute it into the original ODE as y and see if we get the right equality. So the left hand side is y prime, the right hand side is 0 squared times cosine t, and as you see, it is indeed 0 equals 0, so it is indeed the right equality, so which means that y equals 0 is indeed a solution, so, and it is an alternative solution. So, and that's the final answer. So thus the final answer is y equals minus 1 over sine t plus an arbitrary constant, or y equals 0. Well, it kind of looks like magic, but let me try to verify if it is true. Right, so let us try to write it y equals minus 1 over sine t plus constant, and let us see if it makes our equation into a correct equality. So the left hand side of our differential equation is the derivative of this with respect to t, so we should write minus. Then when we are differentiating 1 over something, we are going to get minus 1 over this thing squared, sine t plus c squared, multiplied by the derivative of sine t plus c, which is cosine t. And so which is cosine t divided by sine t plus constant squared. Okay, now the right hand side is y squared. Our y is minus 1 over sine t plus constant so this is our y, so we should square the whole thing times cosine t. Well, and clearly it's exactly the same thing as the right hand side, so which means that letting y be our formula makes our equation into a correct equality, into a true equality, and therefore it is indeed a solution. So notice just one more thing, that somehow we have magically found infinitely many solutions of our differential equation, but we couldn't prove that it's all that are possible, that there is nothing else. So in order to prove that indeed there is nothing else, that this method indeed gives us all solutions, then we need to I need to explain how this method works in theory, and I need to prove that it is indeed a correct method.